Okay, hello everyone. As usual, how did the homework go? Do you have any questions? Please start putting them on chat. So I have an idea what your questions are. Can you go over number 40, please? Okay, definitely. Any other questions? So please put them on chat, all of you. And I will pick up the problems that you guys asked me. Before I do that, I would like to ask you very simple questions while you guys putting your questions on chat. I'd like to ask you some questions. Suppose, okay, I have a graph of a line. So I have a line, this line, and we have to be a bit clear. Give me 1 second, Grace. I will get back to all your questions. So suppose I have a line like this, and a student write the following. He tells me that the equation of the line is 2x plus 5. Okay? How do I know immediately that the student is wrong? Okay, what is, immediately I look at it, I said, you know, this is wrong. Why? I said it's wrong. The line doesn't go through 5. The y-intercept, exactly. The y-intercept, the b, this value here, tell you what happened at 0. So if x equal to 0, your y should be plus 5. However, here my intercept is negative. That's the only thing we know. Okay, so immediately the student is wrong. All right, so that's one thing that sometimes I look at your work and you will have like the intercept wrong, but you, in a very easy way, you should know at least that you should have the correct intercept in the problem. All right, another simple questions also along the same line. Okay, a student have that, and the student wrote for equation 2x plus 5. Immediately, how should the student say immediately that his answer is wrong? Exactly, what's happening? The slope. So sometimes the slope here is negative. The slope is absolutely negative. So if we go 1 unit, we have to go down here. So the change in y, if you want, will have to be negative. The slope is negative. It means just immediately you should know that your answer is wrong. So these are simple things, nothing really hard, but you should be careful with when you get your intercept. The b is your output when the input is 0. So you should know that. Now, another question, and here it is. Let us say I gave you the following line. Okay, let me change the paper. And this is the line. Okay, and this is my line. And I gave you 2 points. So this is a point. So whatever, let us assume this is 0, 5, the point. And this is another one. Let me say this point is 2, 8. So I have those 2 points on the line. And let's see what's the slope. Let's compute the slope. So if I have 2 points, the slope should be, so as I always did in class, so this is the x and the y, 0 is 5, and let's see, 2 is 8. So the slope is 8 minus 5 divided by 2. So the slope is 3/2. right? And I gave you a problem here where I'm giving you the intercept. So I'm basically, in this particular problem, I gave you the intercept. So the student wrote the following for the equation. Y equal 3 over 2x plus 5. What happened? Why the student is getting this wrong? Why this is wrong? Right. A lot of you, I think, are getting that. Why this is wrong? There is no divided by 2x. Exactly, x cannot be in the denominator. So when you write this, you have to be very careful in the way you write it. That's the slope, parenthesis, times x plus 5. And that's how we should write this equation. Okay, so when I'm looking at what you guys have done, I think a lot of you got stuck in here. So if you write, it's like you're working on a calculator. If you take your calculator and you say 3 divided by 2, and you don't put the parenthesis times x, the calculator doesn't understand you. You have to be very clear what you're doing. The calculator will understand 3 divided by 2x. That's really, and that's not really what you want. This is the slope times x plus 5. So that's another mistake that I thought it's really was giving you problems. All right, so it's parentheses. Parentheses are crucial. Parentheses are crucial. All right, so this is the mistake I've noticed on Moodle. Now I know that you guys are asking me questions. I'm trying to figure them out though. That's what I kept saying. Okay. All right. The model assignment kept saying my answers were wrong because I need to have numbers on both sides of the equation. This one I cannot answer. I don't know what you mean by that, Grace. Okay, I will look at your homework and see what does it mean. Okay. So before I take up your questions, just for my own peace of mind, not for yours, for mine. Suppose I give you 2 lines. I just want to make sure you understand this. And this is, I call this L1, and this is, I call it L2. And my question is, I give you, just make sure every one of you can answer those easily. And the other one is minus 3x plus 5. I call this A, and I'd call this B. I want you to match equation to the line. Which one is A? Which one? So both of them have the same intercept. I made sure of that. Okay, which line correspond to A and which line correspond to B? Okay. Or what's the slope is our really, so this is the slope is -2, and this is the slope is -3. So Elijah is telling me L2 to B. L2 is to B. Do you agree with him? Do you agree with him? Absolutely. Which is one? This is -3. It means which one is going down more? This is the one who's going down more because for 1 unit, that's really what the slope is. What happened for 1 unit? This is going down by 3. That's the one which is steeper. And this one is the one going down by 2. So this is L2 is the line for B. Okay, so these are the small questions I would like to ask myself. Now I go back to you guys. So I can see number 40 that you ask. I will do that. And if you have any other questions, please feel free. So let me look at number 40. Okay, so this is the number 40 is from your practice problem. Number 36 too, please. Okay, so that's number 40. We read it together and we do it. So the population of a particular town in the state of New Jersey was 9,000 people in the year 2000 and is shrinking at the rate of 20 per year. The population in Maryland was 5,000 in the year 2000 and is growing at the rate of 100 people per year. Okay? And the question is, when will the population of the town in Maryland be greater than the population of the town in New Jersey? So let us take the problem and read it again till we understand it. So we have two populations here. So we have New Jersey and we have Maryland. New Jersey. In the year 2000, New Jersey had 9,000 people and growing, and shrinking. The population is decreasing by 200 per year. Every year is going down by 200. Maryland, in 2000, it was 5,000 people, but it's growing. So growing by how much? 100 per year. So this one is decreasing and this one is growing. So the question is, when will the population in Maryland be greater than the one in New Jersey? So this is going down, this one is going up. At some point, Maryland is gonna, have more people than in New Jersey. And the question is, when does this happen? So how can we do such a problem? Okay, let's think a little bit. Let us find a formula for the population in New Jersey. Is it easy or hard? So we're gonna call f of t to be the population in New Jersey at time t. Okay, where t is number of years after 2000. So that's my first function, after 2000. Right? Okay, do we know an easy formula for f? Is it linear? Question number one. Is f a linear function? Yes or no? And what give it away? Every year is growing by 200. So every year, that's what it is. It starts by 9,000, at t equal to 0. We have 9,000. After 1 year, it's going down by a 200. Okay, so it's going to give me 8,800. Another year, another 100. That's a constant rate. So the population is what it starts with minus 200t. That's the population in New Jersey. Okay, now, what about Maryland? So we can introduce another function. We call it g of t. G of t is the population in Maryland. In Maryland, t years after 2000. The year 2000. Again, g of t is linear. Why g of t is linear? Because it's increasing by the same amount every year. So every year is increasing by 100. So the population in Maryland is what it started with, which is 5,000 plus 100t, or 100t, or 100t plus 5,000. Okay, so that's the population in the formula for Maryland and the formula for New Jersey. And the question is when this population will be larger than the population here. So let us do a graph. So let's understand this problem totally graphically. Okay, all right, I'm gonna sketch two graphs. I want to sketch the graph of the population in New Jersey. And then I'm going to sketch the graph of the population in Maryland. In New Jersey, it started at 9,000. That's what's happening. And every unit of time is going down by 200. So the population is going like that. So that's New Jersey. Okay. What is Maryland doing? Maryland is starting here at 5,000. But every year it's going up. So that's Maryland. Okay, that's Maryland. So if we look at the graph here, just graphically, of course, we're going to do things algebraically. So at the beginning, in 2000, of course, New Jersey had more, but New Jersey kept losing. Maryland kept gaining. At some point, Maryland has more people. And the question is, when does this happen? So how do you want me to solve this problem? Back to you. So I drew the picture, I think, and now I go back to you. How do I know when will Maryland start having more people? Anybody? Okay, g of t is when g of t is larger than f of t. So one way we can do it is we're gonna find when they are equal, just because I'm trying to use the picture for now, and when they are equal, and after that, the Maryland will have larger. Okay, so we don't need to plug in times because plug-in number sometimes doesn't get us the exact value. So how we're going to find? We're gonna find time t when the population are equal. I'm using the picture. After that, Maryland will have. So we're gonna find when they are equal. So when the output of G is equal to F. All right, so that's how we're gonna do it. First, we're gonna find the time. When is G, it means Maryland, equal to New Jersey? Which time they have the same output? It means when we have the same population. Once I figure this out, then I can answer my question. So we're gonna find the time when both equations will give me the same output. All right, so how we do that? G of t is 5,000 plus 100t. And I'm asking, which time this would be exactly that. I need to solve for t. Yes, Cooper, you are absolutely right. I can do that, but I'm gonna do it both ways. Okay, I'm gonna do it both ways. So first I'm gonna find when they are equal and then proceed. Okay, so is it easy to solve this equation? Is it easy to find when they meet? Okay, I need to isolate my t's. So I add 200 both sides. So I'm gonna add 200t both sides. So I will have 100t plus 300t equal 9,000. It means, and then I take away 5,000. So I will have 400t from here, which is 9,000 minus 5,000. It means 400t equal 4,000. Now I solve for t, which is 4,000 divided by 400. And now you can either pick your calculator or you can do it, which is equal to 10 years. Okay, isn't 300t? Of course it is 300t because I goof sometimes. Thank you very much. I should give you +1, Sage. I usually give student X point because Okay, my apology. I should add 200, which is going to give me the 300. Thank you very much, which is 9,000 minus the 300t is equal for that. So now I have to divide by 300. And if we divide by 300, we should get 40 over 3. That's why I don't want to plug in numbers, because plugging numbers is problematic, which is almost 13.3 years. Okay, so if I had plugged in numbers, it would have been hard for me to find 13.3. That's why we have, and this is repeating. Okay, so what's happening then? It means after 13 years, a little bit over, so this interrogation mark is basically 13.3 repeating. It means after that much time, they have the same number of people. So Maryland will have more people when T is larger than that. So Maryland will have more people. So Maryland will have more people after that. Okay, we'll have more people when T is larger than that. And that's when this happens. All right, so Cooper is telling me that almost around, so it's almost around, since T equal to 0 correspond to the year 2000, after 13 years, almost 2014, or to be more accurate, somewhere between 2013 and 2014. So somewhere between 2013 and 2014. Okay, and that's really how we do this problem. All right, so the main idea here is I have two functions and I would like to know exactly where they intersect, where they meet. So how do I find where they intersect? I say, okay, they intersect when. So I want to find the input where the output from both functions is the same. So I said the outputs equal to each other. That's what we did. And we solved for the input. So whenever we want to find the intersection, that's what we do. We set the output from both functions equal to each other. All right, does this make sense? Any questions about it before I move to the other question that I was asked, which is number 36, all right, clear, thank you very much. Let's move on. So let me look at number 36, and again, we looked at it, so, okay, here we are. So number 36, okay. So let's read it. The under 5 mortality rate for the children born in the USA and Germany are given in the table below. And the data was basically a correct data. So this is not a made up data. This is the number of children per 1,000 live births that die in each country before the age of 5. So in the year 2000, for among kids less than 5 years old, 8.5 out of 1,000 kids born died. In the year 2001, 8.4 out of 1,000, not 8.4 kids, 8.4 out of 1,000 died, and 8.3 out, and so on and so forth. In Germany, okay, as unfortunately, not for us, basically, they have definitely a better mortality rate than we do. So while in 2000 it's 5.4, if 8.5 for us, it was 5.4. So definitely they have better mortality rate than we do. So out of 1,000 children who are under 5 years old, in Germany 5.4 passed away. However, here is 8.5. So definitely they're doing better than us. Question number 1 is, let f be the function that to each year t assign the number of American childhood deaths per 1,000 live birth in the year t. Is f a linear function? Question number 1. Is f linear? Means, is their average rate of change the same? Is it increasing at the same rate? So we go back to the picture. What do you think? Is it? Did you guys look at it? Yeah, absolutely. Because from here to here, the change is 1 in population, sorry, in years. And the change in the amount of deaths went down by 0.1. From here to here, so by luck, they gave me the same change in X. I don't have to me. Went down by 0.1. From here to here, it's the same change. So that's a 1. Went down by 0.1, by 0.1, by 0.1, by 0.1, by 0.1, 0.1, 0.1. So definitely, so number 30, now let us take the number. So part A, all right, so we, regardless, so we have the change in the population basically over the change in X is constant, and it's equal always to 8.4 minus 8.5 divided by 1. It means minus 0.1. So this constant across the board. It means linear. Okay, now it's linear. They want me to find a formula for it. So what is the formula for it? And t equal to 0 correspond to the year 2000. Okay, so what is the formula? All right, what do we have? It's linear. To find the formula, I need the slope as a point. So what are the points I have? At t equal to 0, because 0 corresponds to that year, they don't have to. Okay, the population is 8.5. At t equal to 1, the population is 8.4. So what is my formula? The slope is minus 0.1, minus 0.1 t, plus, in this particular problem, and I repeat, I have the intercept. So that's the formula for F. Very good. Now, what about Germany? The question is G linear? It means, are we going down at a constant rate? Now, by luck, they don't have to give me the same change in input, but here they give it to me every year. So now Germany, I watch from here to here, it was 5.4 per thousand, 5.2, so we went down by 0.2. Now from here to here, we went down by 0.1. So in 1 year, we went down by minus 0.2, in another year, minus 0.1. Is G linear? No, we don't have to go on. I'm done. We don't have to go on anymore. Okay, because if I compute the change over the change, I'm going to get minus 0.2 here. If I compute the change over the change, I'm going to get minus 0.1. Definitely G not linear. So B, G not linear. Not linear. Okay, because if I compute the change of Y is not constant. It's not the same, I'm changing. Okay. Now C, which is I imagine what you must have difficulties with. So I read C and see what you guys will have to do. What is C about? If the mortality rate of children in the USA indicated in the table continues in the future, it means that if the mortality rate keep following this formula, stays this one, that's really the mortality rate. In what year will the USA have the same mortality rate than Germany did in the year 2000? Means how long it's gonna take us to catch up with Germany into year 2000. And Germany is really, I mean, there's a big difference between both of us. But if you wanna catch up with Germany in the year 2000, how many years and how many years after 2000 this will occur? How shall I answer this question? So my goal is when we'll even have the mortality that Germany have in 2000 if we keep at the same rate by going by 0.1 every year. when will we reach Germany in 5.4? So how shall I do this problem? So we have to find the time such that, finish my sentence. How long is gonna take us? F of t is the mortality rate for us. So t equal to 0, the mortality rate 8.5. T equal 1, the mortality rate went down, 8.4. T equal 2, okay, it went down by another one, we're at 8.3. And the question is, when will we have the same mortality rate as Germany in 2000? So Germany in 2000, I'm being slowing down because I want answer from you, of course. Germany in 2000, which is the time t equals 0 for us. So Germany, the mortality rate is 5.4. Okay, and I need to ask, when will we have this mortality rate? How shall I do this problem? Yeah, I'll give you a minute to think about it. What will I do? I want to do it algebraically. What should I do? Yeah, Kirsten, Duzan have it correct. What shall I do? It means I need to find the t when this f of t, which is the mortality rate in the United States, at what time the mortality rate in the United States is equal to 5.4. That's exactly what I want. When our mortality rate will reach 5.4, it follows this formula. So I need to set this equal to 5.4. So we have to set and solve for t. Okay, now the question becomes simple. So now what do I want to solve? So that's minus 0.1t is 5.4 minus 8.5. So this is gonna give me minus 0.1t equal. All right, now we do a little bit of math. So this is 5.4 minus 8.5. It's gonna give me minus 3.1. Okay, and then what's t? To get t, I need to divide both by minus 0.1. So I will have t equal minus 3.1 divided by 0.1. So this is going to give me how much quickly? This is going to give me 31 years. Okay, so in the year, if the same pattern continue, in the year 2031, the mortality rate in the USA, the mortality rate in the US will reach 5.4. Okay, so if the mortality rate keep going down at the same rate, then it's gonna take us 31 years to catch up with Germany in 2000. So we have a long way to go. I hope you will do better than that. All right. So always ask yourself, set up equation. Ask yourself, what's really the question wants me to do? Here they want me to find when will this be equal to 5.4. So I give me the output, and then I have to set up my equation. Okay. Any other questions about the homework? All right. I would like to discuss the one that I wrote for you, and let's see what you guys have done with it, and then we proceed. Okay, so this is the problem I put on Blackboard, I'm sorry, on Brightspace for you. And along the same line, you guys should, I don't know if you guys done it or not. I hope you did. And let us talk a little bit about it and then we proceed. So the profit in dollars of selling n items is given by f of n equal 0.8 n minus 3,000. So it means that, what's the problem about? Okay, you have a store, okay, and they have a specific item, let us say, you know, a calculator, and the profit from selling n items is given by this function. So this time they give us the function. My question now is the following. If you want to sketch the graph of this function, what should go on the horizontal axis and what should go on the vertical axis? So before you answer me this question, what is the input here and what is the output in this particular problem? What am I looking at as input? What am I looking at as output? Anybody? I mean, number of items sold and profit earned. So here, f of n, so that's really my function. This is my rule. I input the number of items and my function will give me the profit from selling this item. From selling those items. So if I want to graph this function, that's the graph. What should go here? Quickly. What goes on the horizontal axis? The number of items. So this is n, number of items, always the input. And here, the profit, the output. All right? Okay. Now, question is number 2. Identify the vertical intercept. What's the vertical intercept in this problem? What's the unit of it? And what's the meaning of it? All right, so let me write this function again. F of n is 0.98 times n minus 3,000. So what is the vertical intercept? Okay, the vertical intercept is, as I said, is the output when the input is 0. So the vertical intercept, it means what happened when, so the vertical intercept is basically the f of 0. That's the vertical intercept. It's what happened at when the number of items is 0. This is minus 3,000. Now what is the unit and what's the meaning of it? What's the unit? Minus 3,000 what? That's the unit. What's the meaning of it? So what does this represent? So if n is 0, no items are sold, that's what means n 0, then the profit is minus 3,000. Does this make sense? Does it make sense to have a negative profit when no items are sold? When no items, when 0 items are sold, there is negative profit. Negative profit. Does it make sense? Why there is negative profit? Anybody can give me a quick answer? That's right, the money you have to make before you can have a profit. So you can call this like the overhead. You know, before you make a profit on an item, of course, you have a lot of things. You have to open factories, you have to train workers, and so on and so forth. So before, even if you sell a lot at the beginning, but still you have to compensate how much you pay to produce the item. And that's really what the negative is here. All right, question number 2. What's the slope in this problem? And what's the unit? What's the slope? So that's a line because n is my variable. It's m times n. So that's minus b. So what's the slope in this particular problem? Can we read it off the formula immediately? The slope is exactly the 0.98. That's the slope. And now let us understand why it is the slope, 0.98. If I put the number of items and I put the f of n, if 0 minus 3,000, after 1 unit, what is the number? It's 0.98 minus 3,000. Means from here to here, we are minus 3,000, we added 0.98. So, okay, so my slope here is the 0.98, it's this term right here. I add one extra item, again, another 0.98. So the slope is nothing more than what's the n, what's your variable multiplied by. Now, what is the unit of the slope? Look at this, try to make sense out of it. What's the unit of the slope? And what's the meaning of it? So what does the 0.98 represent? Profit per item sold is marked correct. Watch carefully. Every time the number of items increased by 1, my profit increased by 0.98. So the slope is $0.98 per item sold. So it's always the unit of the output, whatever the output is. So that's very easy actually to even memorize this. Whatever your output is over the unit of your input. Whatever your input is, it doesn't really matter. That's what the slope is. It tells you by how much your output. It's the profit increase every time your input goes by 1. Okay, so it's $0.98 per item sold. It means every time you sell one more item, your profit increased by 0.98. Sometimes you can think of this as the price per item in this particular scenario. It means the profit increase. What does it mean? The profit increase by $0.98 for every item sold. Every item sold. Every time we sell an item, that's what increase. All right, so the rest should be, so this is the understanding the formula. Now, how many items should the company produce to start making profit? Okay, so that's the profit. We have a formula for it. Of course, we're starting at minus 3,000, but the profit is increasing. So the picture for us is like this. That's the n, and that's the profit. We write down here at minus 3,000, and then we start increasing a little bit, very little, because it's 0.98 cents, and we are really down by that much. So it's going to be somewhere like this. So my question is, how many should we produce so we can start making profit? What do you think I should do? What do you think? 3,000 over 0.98, yeah, what kind of formula we need to set up? In the picture here, what should I look for? Your answer is correct, Connor. What should I look for in this picture? When do we start making profit? Before that number, whatever this number is. Yes, there is no profit up to here. Because for now, whatever the number here, the profit is negative. We start making profit after this number. Now we have the profit. So how many items should the company have to start making profit? First, we want to see when the profit is 0, and after that, it start making profit. So the first, we're going to set our equation equal to 0. And after that, we start making profit. So we basically are after this number. So now we solve, and that's where Connor, right, Connor, yeah, gave me the answer. N equals 3,000. It means number of items is 3,000 over 0.98. And I did not compute this number. I hope one of you did. So how much is going to give me? So it's 3,000 divided by 0.98. And this gives me almost 3,061 item. Means we have, so this interrogation mark here is 3,061. It means we have to make more than that to be able to make profit. After that, before that, the profit is absolutely negative. There is no profit. All right, the last question is easy. How many items should be produced for the profit to reach $6,000? If I want the profit to be 6,000, how many should I produce? Okay, so 6,000 should be somewhere in here. And my question is, that's the profit. How much should I produce to do that? Which equation I should set quickly? So what am I giving you now? What you guys should go after? I'm giving you the output, 6,000. And I'm asking you, what is the input that give me the output of 6,000? Now the rest is simple. So we add 3,000 both sides, would give me 9,000. And then I just have, sorry. Okay, 98n equal 9,000. It means this couldn't give me 9,000 divided by 0.98. And now the rest is plugging in, which is gonna give me 9,183.67. So we have to produce that many items. Okay, any other questions? Okay. The last few minutes before you guys take the quiz. First, I would like to tell you that exam number 1 is next Thursday. That's your first exam. And you will guys, you will have a review. I'm working on it this evening. The review will be on Brightspace. So you guys look at it, not look at, do it. And it will cover everything we did. So you guys have a lot of quizzes to work with. You will have to review to work with. And on Tuesday, you can ask any questions that you want about anything that you don't understand. All right, the last thing I want to do, because we are heading toward the exam, I will not start chapter 2. I will go chapter 2 after the exam. But I want to do a little bit like 2 problems, which is more algebraic skill, not really some algebraic skill problem. I would like to do 2 problems. I will assign some for next time. Yes, the review will be tonight on Brightspace. Okay, I am working on it. I still have a little bit, and I will send you an email when I have it out. So you can start working on it basically tomorrow, okay? And you can ask me questions as you move on. The review is your homework for next week, plus the 2 problems I'm gonna do now, all right? I'm gonna do 2 problems now. This will be part of your homework for next week, plus the algebraic skill. But there will be no online homework because I want you to work on the review. There will be no online homework for next week. Okay? I hope I answered the question. I don't know. All right. So the algebraic skills that we really developed, this is usually, I think, in section 1.7, are something like that. So let us say I'm gonna ask you to solve the following equation. I would like to do 2 equations with you. Suppose I ask you to solve the following equation, simple one. X minus 2 over 2x plus 5 equal, let us say, minus 4. All right, so this is only an algebraic skill here. All right, how would you do that? I think I did that once before, but I would like to repeat it. How would you solve this equation? First, what's bothering you, and then how we're gonna solve it. Exactly. None of us like the 2x plus 5 down here. We have to multiply both sides by 2x plus 5. So I will have x minus 2 over 2x plus 5. I multiply, that's crucial, which is minus 4 times 2x plus 5. Obviously, the goal is to be able to simplify this. And then this will give me, this is equal to, we have to distribute, minus 8x, distribute minus 20. And that will make the problem much easier to proceed. And now I solve. I add x both sides. I add 8x both sides. That will give me 9x. Minus 2 is minus 20. Add 2 both sides. 9x equal minus 18. Well, that turned out to be simpler than I thought. Divide by minus 18, which is going to leave me with minus 2. Okay, so just simple algebraic skill that you guys will need. I'll do one more along the same line, and then I will assign some for next time. Another problem is solve the following. And 3 plus something like the square root of x minus 2 equal to 7. Solve means find the value of x such that this is satisfied. And, oh yeah, okay, Amanda, I will. All right. All right, how can I handle this type of problem? Okay, I subtract 3. So the idea here is square root bothers me, of course. We need to isolate it. So isolate. Isolate, always. So to isolate this, I have to take away 3 from both sides. So subtract 3. So this will give me 7 minus 3. All right, now it means it's going to give me a 4. Now I want to get rid of the square root term. But we know there is one way, in a way, to get rid of the square root. And here, so I said, since those are equal, it means if I square the first term, those will be equal. Now, this, the definition, the square root is the number. That's the definition of it. When you square it, you get a back. That's really what the square root is about. So it means that x minus 2 is 16. It means x equals 16 plus 2, x equals 18. Now I can plug in 18 back and make myself, am I right? If I plug 18 back, 18 minus 2, that's a 16. The square root of 16, it's a 4. 3 plus 4, 7. My equation is satisfied. Okay, so there are simple algebraic skills that they are necessary. And of course, I will test you over that. Okay. You have any questions about this? Let's do one hard one, not one hard one. Another one, and that will be the end of it. So suppose I give you the following. Okay, solve the following equation. X over, don't be afraid at all, it's not hard, minus 3x plus 3 equal to 1. I said, don't be afraid of that. What shall I do? And I will do that slower, Amanda. I don't subtract 3 and then square both side factor. I don't follow this time. Okay, what do you think you do? Okay, this look awful because I have this denominator, right? So what we're going to do? I'm going to multiply, as simple as that. Multiply both sides by the denominator. Okay, so we will make the problem easier for us. Means I have that equal to 1. I'm going to multiply this side and this side by this. Okay, now the benefit of doing this, of course, is that this go. And then I will have x equal x squared minus 3x plus 3. So I made it into, this had a fraction equal to 1, which is really a nightmare. So I said I multiply by both denominator and I turn it into this equation. And now, how do we solve something like that that involve it x squared? Remember what was, how did we do that? I remember telling you what you should do. Cooper, you're right. How do you do it? No guessing. I mean, guessing is wonderful, but how can we do it? Combine like term. All right, Kayla, what do we mean combine like term? You guys are correct. All right, subtract x from both sides. They're absolutely right. I would like to make 1 to be a 0, so I can factor. Right, so to be able to be 0, we're going to subtract, take away x from both sides, because I want this to be 0. So it will give me x squared. If I take an x from here, I'm going to have minus 4x plus 3. So a problem which looks on the surface quite complicated, it was not that much. And now I factor. So I have to look for two numbers. When you multiply them, you get 3. And when you add them, you get minus 4. So 1 and 3 seem to do the job. And because I have this minus in here, it's going to give me that. What does this mean? It means that the product is 0. It means either x minus 1 is 0, x minus 3 is 0. The first one will give me a 1. The second one will give me a 3. End of the problem. All right. So for Tuesday, I will give you like 4 problems, 4 or 5 along those lines. They will be from your book. They will not be from Moodle. Moodle, I don't think they have those. And then the review. So it should not be a lot. And please get started on the review. I promised you tonight, I hope to have it out. All right, any questions? Any questions? All right, so please go to your quiz. As usual, you go to content area, quiz number 5, and get going. The format for the exam, it's like the quizzes, basically, probably more problems. Some may be a bit harder because you guys have time, but nothing really that you're not used to. And it will be on Zoom, so I will be with you all the time.